Episode 2, How Blockchain Works. Welcome back to our blockchain and cryptocurrency series. In Episode 1, we introduced blockchain and cryptocurrencies. Today, we're going to dig deeper into how blockchain technology works, covering decentralization, peer-to-peer networks, how transactions are recorded, and the role of miners. By the end of this episode, you'll have a solid understanding of the mechanics behind blockchain. Let's get started. To begin, let's talk about decentralization, which is one of the key features of blockchain technology. In a traditional system, like a bank, all the power and control over transactions are centralized in one location. A bank holds a ledger, and it decides who can access the ledger and how transactions are recorded. However, in a decentralized system, there is no central authority. Instead, control is distributed across a network of computers, called nodes, all of which work together to validate and record transactions. This type of system is called a peer-to-peer, P2P network, and it's the foundation of blockchain technology. In a peer-to-peer network, all participants, or nodes, are equal. Each node has a copy of the entire blockchain ledger, and they communicate directly with each other. When someone initiates a transaction, it's broadcast to all nodes, which then work together to validate it. This decentralized peer-to-peer approach ensures that the network doesn't rely on a single point of failure and is more resistant to hacks and fraud. It also allows for greater transparency because every participant can see and verify the transaction history. Now that we understand decentralization, let's take a look at the mechanics of how transactions are recorded on a blockchain. A blockchain is essentially a chain of blocks, and each block is a bundle of transaction data. Think of a block as a page in a ledger. When you make a transaction, the details, such as who sent the money, who received it, and the amount, are grouped together with other transactions into a block. Each block contains three main components. 1. Data. This is the actual transaction data, like the sender, receiver, and amount for each transaction. 2. Hash. This is a unique identifier for that block. It's like a digital fingerprint that distinguishes it from every other block. 3. Hash of the previous block. This connects the block to the one before it, forming a chain. It ensures that all blocks are linked in chronological order, creating a secure and immutable record of transactions. When a block is full, it gets added to the chain. Since each block contains the hash of the previous block, any change in one block would invalidate the entire chain. This is part of what makes blockchain so secure. Tampering with one block would mean altering every block after it. So, how do we actually add a block to the blockchain? This is where miners and consensus come into play. Mining is the process of validating transactions and adding them to the blockchain. In a decentralized system, we need a way for the network to agree on which transactions are valid. This agreement is called consensus. Different blockchains use different consensus mechanisms, but one of the most common is proof of work, POW, which is used by Bitcoin. In this system, miners compete to solve a complex mathematical puzzle. The first miner to solve the puzzle gets the right to add the next block to the chain and is rewarded with new cryptocurrency. This is called a block reward. Here's how it works in simple terms. Miners use powerful computers to guess the solution to a puzzle. This puzzle is based on the data in the block and the hash of the previous block. Because the puzzle is so complex, solving it requires significant computing power and energy. Once a miner finds the correct solution, they broadcast it to the rest of the network. Other nodes then verify the solution, and if it's correct, the block is added to the blockchain. This process of solving the puzzle and adding blocks ensures that everyone on the network agrees on the state of the blockchain. This is the consensus. And because solving the puzzle is so computationally difficult, it's incredibly hard for any bad actor to manipulate the blockchain. While proof of work is the most well-known consensus mechanism, other systems are gaining popularity, especially because POW can be very energy intensive. One of these alternatives is proof of stake, POS. In proof of stake, instead of miners solving puzzles, Participants in the network are chosen to validate transactions based on the amount of cryptocurrency they hold, or stake. This method is seen as more energy efficient and scalable compared to proof of work. Different blockchains use different consensus mechanisms, but they all aim to achieve the same goal, ensuring that everyone on the network agrees on which transactions are valid. So, why does this technology matter? Well, blockchain's decentralized nature and consensus mechanisms mean that it's much harder to tamper with data or transactions. This makes it a powerful tool for building trust in digital environments where you don't need to rely on a central authority. For example, Bitcoin has proven that we don't need banks to process financial transactions. Ethereum, with its smart contracts, shows that we can create decentralized applications that run exactly as programmed, without the need for intermediaries. In today's episode, we've explored how blockchain works, covering the importance of decentralization, peer-to-peer networks, how blocks and chains store transaction data, and the role of miners and consensus mechanisms in validating transactions. In the next episode, we'll explore different types of cryptocurrencies and dive deeper into how Bitcoin, Ethereum, and other major cryptocurrencies operate. Thanks for joining me today, and I look forward to seeing you in the next episode. If you're finding this series helpful, be sure to subscribe and leave your questions in the comments. See you next time.